Hang on. Trying to find out if I'm live yet. Well, I just got an email saying I am live, so, yep, I am live. As always, whoa, hold on. Echo. That's not good. Okay, there we go. As always, there is a, live chat. So, say something. That's wrong. Let's see. There we go. That's the right camera. Hi. So, today I'm going to be designing a, thing. It's for, Yes. Yes, that is... Don't block the microphone, dummy. Don't hit the microphone, dummy. Okay, so what was I saying? Yes, filament. 20... Look at the camera. 22, pounds of filament. Right here. So, obviously, my printer is not that big. So what I want to do is make a bearing so that this thing can, spin freely, and maybe it'll have a hope of actually pulling filament off of it without it getting messed up. So, let's start designing that. So, let's see. I have too many cameras. That's, again, wrong. That's right. Apologies for this camera. There's everything about it is wrong. But what I want to do is have a plate. It goes here. Goes in this hole. Goes in this hole. Bearing that sits here. And then an inner shaft that will then slide on some 3/4 black tubing. 3/4 because I'm hoping I can get those clamps that they use for lifting weights. I forget what they're called, but I don't lift the weights, so. But I'm hoping that I can just do that so I can put a clamp on it and not actually have to tighten anything. So I'm hoping to make this easy. So let's switch cameras. First, let's fix my microphone since I knocked it. There we go. So, scene 1. Yeah. No, wait, that's wrong. I think it's 3. Yes. So, first, this is Fusion, right? Right here. Can you see my mouse? Good. So, let's move to the front view. Now, I'm not an expert in Fusion, so if you're saying that what I'm doing is wrong, go right ahead, because I don't know any better. But I start out as a drawing, choose the face, drawing on the front. Let's start off with a circle. Let's say 6 inches. This is actually really difficult with a 22-pound spool of filament on your leg. So circle. What did I say? Technically 5 3/4. Let's do 5 3/4. Why not? 5.75. Okay, so that's our circle. Now this is only in 2 dimensions. I'm going to get rid of this thing. Oh, I can feel my legs again. Now I'm getting feedback in my headphones. So, this is 2 dimensions, as you can see. 2 dimensions, but let's create 3 dimensions by going to create, extrude. Let's extrude it out half an inch. So, there's our circle. Let's go back to the drawing. Go to sketches. Make it visible again. Right click. Edit sketch. So we need to make the, let's start with making let's start out with making, heavy. I knew I shouldn't have put that away. Let's first, grab that whole dimension. .532. Of course, you have to take tolerances into consideration, so let's make that just checking something. Let's make it 1.52. It's 1.53. I want a bit of a snug fit, so 1.52. And I have yet to find any specifications for fitment on printed parts. I don't think anybody has actually done any work on that. Let's make, how thick is this? And let's make it 0.2 inches. So go back to create extrude. Let's make, why can't I hit it? This thing doesn't show bodies when you're drawing. Let's hope this way is correct. 0.2 inches. Oh goody, it is. Okay, let's go back to that sketch. Now, I want to make that circle. Okay, that's bad. That camera died. Rats. Did it just die, or... Oh, that's my 3D printer. Oh yeah, that's what we call that. Well, that's next, so, oh man, I'm having all sorts of issues here. Ah! Don't want that. Sorry about this, guys. All my cameras just froze except for my screen capture. So, we're stuck with this. Okay, so if you saw that second hole, that's what I'm making. You know what? Wonder if I should try restarting this. That works. That doesn't. You know what? I'm going to be back. I'm going to try restarting this program. So, be back in a minute or two. Hang on. Might help if... Okay, video's working. Let me just repost the new link. Oy. I don't know why that happened. I like my noisy keyboard. I do. Bothers people. But not as much as the fans. That you probably hear that I forgot to tell you about. There's a server right over there, so that's why you hear... That's why it sounds like I'm in a wind tunnel. Let me just, do something. Can't think and talk and do stuff at the same time. Pasting in link now. Posting. Okay, so, okay. Hi, Green Army. Glad you found the new link. I have no idea what happened. It just stopped working. So let's get back to what we were doing. I don't know if any of that actually made it out. I don't know if my audio was working. So let's stop sketch. So here's what we have so far. So that will... I'm showing you, and I don't have this right camera. Oh man, this is just going all wrong tonight. So, this is what we have thus far. The main cylinder. That will go here. Then we got the inner circle that will go in there. Now I need to make that circle. But first I gotta find out where it goes, of course. So let's see. 3.257. So let's get back to the drawing. Edit sketch. Line. Nope, that's wrong. So I measured from here out at 3.25. Let's subtract a little because the circle's going to be slightly smaller. And this is guesswork, so let's just round it off to 2.5. Now let's create a circle, two-pointed circle. I specify one outside point, and I can specify the other outside point. This is the great thing about 3D printing, because I can print this, find out it doesn't fit, and fix it. So that's 0.745. You couldn't make it 3/4. Oh, it's probably metric. That's probably why. So let's make that 7.74, not 74.4. That would be big. Okay, so now we got that circle. Let's extrude that. So 0.2 inches, okay. Okay, so now that should line up right on there. But, as you can see, there's no hole in the center. Well, without a hole, this is useless. Just heavy and awkward. Did the camera die again? I get it. Every time I bend over, it dies. Yes, that must be it. Green Army, let me know if you can still hear me. If you can still hear me, I'm going, because this is ridiculous. I'll just go without cameras. But I'll continue thinking that you can hear me. Otherwise, I'm just talking to myself, which is actually quite normal. So, let's get the bearing diameter. Oh, well, that's wrong. There we go. The only thing that actually works. I'm asking if you can still hear me in the chat without actually saying anything. So, okay, I got the bearing. So let's stop the sketch. Okay, so that's the inside. Let's move to the outside. And I hate it when it does that. Right. No, it's a circle. Doesn't matter. Let's create a sketch. Okay, that's good. So we just lost all video except for screen capture. So good news, you don't have to look at me. That's always good news to me. You don't have to look at me all the time. That's scary. I hate editing myself. I just did that. I need a circle. Circle. Okay, so hang on. What do I need to do here? That's not thick enough. Yeah. So I should put the bearing inside, not on the outside. So this has to be much thicker. Or do I just bulge it out? Sorry, I had to clear my throat there. Design decisions. Let's print. I gotta have a flat surface to print on, or else it's not gonna print well. So that kind of answers my question. I just gotta make it thicker. The bearing is 0.56 inches thick. So let's say I want a quarter on the one side, make it 3/4 of an inch thick. So that's actually not hard. Just hit modify, maybe. Sometimes it works, sometimes it doesn't. Push it out. Another 1/4 of an inch. Just type it in, that's simple enough. Okay, so now go to create sketch, circle. Okay, so now I want this to be a tight fit, but I don't want to crack the plastic. This bearing is 2.625 inches. So let's make that 2.63 and a half. 2 point. 1.635. Again, this will I'll probably print this. That's good to hear, Green Army, because I know that's dead. So is it really blurry for you? No, never mind. I have it on lowest quality, so that's good. So let's... Now, the nice thing about Fusion... I can... Whoops, I just clicked out of the thing. I can extrude a negative. See, if I go in, it actually cuts a hole. So... The bearing is 0.56. We want to have some space in there. So let's say... Let's make it 0.5. That was the wrong direction. Create negative 0.5. There we go. As you can see, it created a void there. Now, we need to make a circle, so let's create another sketch. We need to make a hole. So another hole. The inside of the bearing is 1.49, so let's make it 1.52. That way we have some clearance. 1.52. And then just extrude that all the way through the outside. And now we have a hole. So that should accept the bearing and go onto the spool. It won't, because I have to mess with this. But it hopefully will. Oh, that's disappointing. I just got rid of that circle. Okay, so let's undo that. Can't do that, so... Okay, so, well, you can't see the bearing, but I want to have an inner piece, an inner bushing, so that I can slide on and off easily, and I can lock it. Has something good to ride along. So let's just make that an inch. So undo. Go back to looking at the front sketch. Circle, circle. Let's make that 1.2 inches. That should keep the hole on the other side. See, when I extruded that, I lost that part because the circle was too big. So where'd my mouse go? There it is. Create negative. Cut. And now we got a hole. Now, the thing can sit, the spool can sit on that and lock into that. So now onto the bearing. Let's create a, where is it? Not a group. Maybe I can only do that on one. Oh, create components from bodies. There it is. I'm blind. I did not see that. So, create components from bodies. That creates a component. No, that created 3 components. Like I said, I'm new at this. Create a component from bodies, and just drag and drop those other 2 in there. So now this whole thing is one component, and I can treat it as one entity, but I can actually still affect all 3 bodies if I had to. So that's one nice thing I discovered about this program. So let's create the bearing. Let's create another sketch. Circle. Let's see, the bearing is 2.62. Hold on, let's hide that. 2.62. And then create another circle. I really need to get a new micrometer. This thing's missing the battery cap. 1.5. 1.5. Just that. Let's extrude that, or create that. Create or extrude? They say, yeah, extrude. Like, extrude that out to 0.561. 0.561. Okay, so that's our bearing. Nothing fancy, but we have a reference point for our bearing. So let's hide that outer wheel because we're not working on that right now. Let's just delete some of these sketches. Or I can't do that. I need that for reference. Let's delete that circle, that line. Let's try to clean this up a little. I'll probably need it again, but let's go back to editing that sketch. Edit sketch. I'm going to make that I'm just going to make it 1.5 and hope that, let's make it, this is the shaft that will go into the bearing, so I need to make it tight. And I say 1.45. Again, they don't actually have I haven't found specifications for all this stuff. The bearing is 0.56, so let's make that 0.5. Well, hang on. I actually need to make it. My reference point is not going to work there because this bearing is slightly off of. Well, it's really off of that. Oh boy. I don't know what I just deleted there. Let's get rid of that. Hide that sketch. Let's create a sketch on that surface. So you can select faces and then create a sketch on that face. So circle. What did I say? 1.45. 1.45. Now let's extrude that. So let's make it flush first. Okay, so that's 0.56 inches. Let's make it. No, wait, that should be flush because that's sitting. Yeah. Okay, so that's good there. Let's affect both sides. So you can extrude and modify both sides. So let's move that in. Let's move it in 0.1 inch. There, so that should be clear of the spool carrier thing there, Bob. And let's hide the bearing. What's the bearing? Let's send that to its own component because it's its own component. Rename it. I don't think there's a rename. I think it's just yeah, bearing. Clear. What's clear, Green Army? I like that it's clear. I just don't know what's clear. Okay, let's hide the bearing. I'm trying to work on that. Let's send that to a new component too. I don't even know what to call that. Outer. Let's just call it outer. And let's create a sketch on that face. Create a circle. The size of the bearing. Well, now let's make it a little bigger than the bearing. Let's make it. I really want to make it 3 inches. I mean, that will do me absolutely nothing, but I really want to make it 3 inches. Actually, that will do something. So now, how big should we make this? You can also extrude mobile faces, or create from mobile faces. See, I don't know if I'm going to use the springs or a bolt. If I use a bolt, it's going to be about 1/4 inch bolt. So 1/2 inch, 1/4 on each side, that might be enough. Let's make it a 1/2 inch. Let's make it 3/4. No, that looks too big. Let's modify that. Move it back to 1/2 inch. If it needs to be bigger, I'll reprint it. Okay, so now let's create another sketch. You can see how sketches can run away from you. Create a circle from the center. 1.2. No, wait, this has to sit flush. 1.1. Or not flush, it's got not too snugly though. Let's go with 1.2 and see how that goes. So then extrude that in a negative sense, which means cut a big hole in the center. Okay, hole cut. And component there, and we got the bearing. Let's zoom out a little. And there we have it. That was actually way quicker than I thought. So now we have to send this to the software that slices it and print it. Here's a question now. Is this too big? I have to measure my printer. I think it's like 800 millimeters or something. I don't remember. So I just got rid of it. No, that's the bearing. Oh wait, I actually... So let's save that. Let's print that. So save as STL. Now, Autodesk Fusion 360 does have stuff for printers. Like up here, you can see it says make and with a little 3D printer symbol. I have yet to get that to work. The only thing I have been able to get to work is save as STL. So just then and I always forget this. I gotta change units from inch to millimeters because the software can't convert. It did convert and then it stopped converting. I don't know. It's just weird. This takes you back, way back, Green Army. Did you do some 3D CAD work as a child or something? I know you do 2D CAD work. So I don't know if it's taking you back to earlier today or not. So let's save that. As you can see, I made a folder called 3D print. Uh-oh, you can see all the stuff I made. Oh dear. Let's call this outer filament. I can't spell for beans. Filament thing that I have no idea what to call. That's a really long file name. I think that's the longest file name I have ever created. So now I have a problem. I have to add a source. I did not think of this ahead of time. I should have just done this from the beginning. Just do a full screen capture. Whoops. I should get closer to my... Come on. This is starting to get ridiculous. Yeah, there we go. Okay, so now you should see my full screen. Go to 3D printer. Hopefully nothing embarrassing pops up here. And by embarrassing, I mean like bank account numbers. That's not embarrassing, that's just bad. So, double click that. Now this STL file will open in a program called Cura. Now what this does is it takes a 3D model and it slices it. It cuts it into layers and then creates it creates instructions for the 3D printer to execute. And it's still opening. I'm trying to get the SD card that I always forget and leave in my pocket. There we go. There's the way I get it to the printer for now is SD card. I just inserted one in this stupid computer. My computer is not happy today. Oops, that's the Christmas special. I can't show that. Anyway, so here's the part. As you can see, it placed it stupidly. There's no way to put that nicer. So let's flip it. Flip. Okay, so as you can see down here, this will take 7 hours from my experience. Add 30% to that. I don't know why. So we're doing this in normal quality up here. Layer height, that's what the quality means. Wall thickness, I have 2 millimeters. That's Just makes it a thick wall. Infill. Now, what this does, let's look at the layers here. Okay, so this is showing you layers. So as you can see, this is empty right along here. That's not good because that's not strong. So let's make infill 50%. So it's slicing, it's recalculating everything. And see that? It's created little lines inside. This is a tetrahedral. I don't know what it is, but it sure sounds strong. There's also lines, or grid, line, triangles, cubic, that word, concentric, and zigzag. So like if we go to a grid, I just lost the ability to speak. Not that I ever had it. This creates a grid inside, which adds some strength. I believe a tetrahedral is stronger because it's a three-dimensional shape within it. It can create it's a little stronger on all dimensions. So this is actually set up for TPU printing. So I need to change the temperature from 215 to, from 230 to 215. Keep build plate at 90 degrees is probably fine. My plate runs cold. And here are supports. This doesn't actually require supports, but if, let's say, we flipped it and did something weird like that, slicing, 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 slicing. This is like the deli counter. As you can see, it creates lines here. Those are supports. So if you have overhanging structures, it will create supports to support those overhanging structures. We don't need that because of how cleverly I designed this. Yes, I'm using clever as a loose term by designing it properly. Okay, so that's support. Let's look at build plate adhesion. This is this gunk going around it. That just allows it to adhere to the build plate a little bit better. Probably not needed. That's why I go generally on a flat surface like that. I'll go to a skirt build plate that just, as you'll be able to see, just creates a line going across it. I don't know why you can't unselect it, but it's not a bad idea because it kind of helps prime the tip. So that's it. And then I hit, well, let's see. Let's see if it makes all these layers. And if I really wanted to, I could one layer at a time. Isn't this exhilarating? It's not even loading the whole thing. That's just sad. See, it missed a whole bunch of... There we go. And... We're at the top. So, save to removable drive. And it's saved. So, let's see if I can... Let's look at this file that it created. So this is what it created. G-code. As you can see, there's a lot of codes there. No, I don't want to update. Dumb thing. Let's see. Let's scroll all the way to the bottom. There is 247,226 lines of instructions. Well, minus one. That's technically not an instruction. But as you can see, it just tells the extruder where to move. So G1X 99.625, Y 117.41, E1, that's the extruder, 1079.44847. I don't know if there's a Z, if we can find a Z. No, not really worth it. Sorry, I should get a mute button. Clear my throat. So, I plug this into the printer, and I hit print, basically. So, that's it. That was actually right around the amount of time that I expected. Sorry for the technical difficulties. I have no idea what's happening. I'm clueless. But I will look into it. It's probably because this is my main desktop computer and I have a ton of stuff running. I have 253 tabs open in Chrome, plus everything else. So it's probably a memory leak or something. Anyway, that's it for tonight. So, thanks for watching. Bye. Wait, does anybody have any questions? Let me ask in the chat room. Any questions before I go? So let's see if, if I've actually thought of this ahead of time, I would have asked, then explained the G code, then took any questions. But I'm not that intelligent, so... Printer! 3D printer, it's printing. What's it printing? I don't know. You may find out Thursday before Christmas. You might not. It's not turning out too great. That was a little too loud. Sorry about that. Anyway, this is how I'm monitoring it right now. Now, there is something that I want to look at. You can hook up a Raspberry Pi to your printer and monitor it via a web browser. I really want to do that. I just haven't found the time to do that because I've been busy, basically. Yeah, but it basically runs a web browser on the Raspberry Pi and can control the 3D printer. I really want that so that when I'm not at the printer, because these prints take days, as you can see from this print, 21 hours and 17 minutes, and it's only 56% done. This is going to be probably 48 hours before it's done. No, actually, it won't be that quite that long, but it'll be over a day. I'm not babysitting this thing for a day, and I want to be able to stop it from afar. So the software will be, I can VPN into my network and stop it if there's ever a problem. That's one thing I don't understand about 3D printers. If you ever looked at a CNC mill, they have emergency stops. They have emergency stops for a reason. Things go wrong. I have had this printer crash into the bed already because the power for the stepper motor on the left side popped out. Had to reach and turn off the power. There should be an emergency stop, but there aren't. Why? That's something I want to make. Really, I just want to make a new 3D printer. This thing is okay, but I can make it better. And everything I want to do to it, I could just make a new printer if I had the room. So expect next year a 3D printer build. But by the silence, I'm going to assume that nobody has any questions. So I'm going to leave you at that. Thanks for watching. Have a great night. Bye.